Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithu. In today's video, I'll be talking about a statistical test which is called as the Kruskal Wallis test. Even before I proceed to describe how to perform the Kruskal Wallis test using StatCraft, my request you to subscribe to my channel, also like and share my videos. Let's begin by asking what exactly is the Kruskal Wallis test. Kruskal Wallis test is also popularly called as the H test. This is a hypothesis test for multiple independent samples. Kruskal Wallis test is a non-parametric test. The data used here need not be normally distributed. The Kruskal Wallis test is popularly called as a non-parametric alternative to the one-factor Anova. The next question is, when do we use the Kruskal Wallis test? Remember, one of the most important assumptions of Anova is homogeneity of variance test. When the homogeneity of variance assumption fails, we cannot go ahead and perform analysis of variance. This is when we can go ahead and use the Kruskal Wallis test, since the Kruskal Wallis test, as I mentioned earlier, is an alternative to the one-factor Anova. There are 5 important points that we need to keep in mind when we perform Kruskal Wallis test. Firstly, when we are performing the Kruskal Wallis test, the data need not be normal. I repeat, the data need not be normal. Since the Kruskal Wallis test is a non-parametric test, we do not assume normality. The Kruskal Wallis test can be performed on those data sets which have a very small sample size. The second point here is the Kruskal Wallis test is used to compare 3 or more than 3 groups. But you can also use this test to compare 2 groups. Thirdly, each group should have a sample size of 5 or more. I repeat, each group should have a sample size of 5 or more. This is very important because when the sample size is 5 or more, the chi-square distribution approximates a H test. Fourthly, in the Kruskal Wallis test, we are checking whether the median is the same or not. The null hypothesis here is that the median value is the same. The alternative is that the median value is different. Lastly, typically a Kruskal Wallis test is used when the data is an ordinal variable. With this background, let me now proceed to introduce the data set that I'll be working on. This is the very popularly used data set, which is called as the iris data set. This data set has typical flower characteristics. It has petal length. It also has sepal characteristics. I have omitted all the sepal characteristics and retained only the important variables. One is the flower ID. Second variable is the petal length, which is measured in centimeters. And lastly, I have the species of flower. Let me now quickly apply a drop-down. Let me now apply a filter here. When we apply the filter under the species variable, you can check there are 3 different species of flower: setosa flowers, versicolor flower, and virginica. So we have 3 groups. We will be interested in checking whether the median value of petal length for these 3 groups is the same or not. With this introduction into the data set, let me now proceed to run a Kruskal Wallis test in StatCraft P. What you're seeing in front of you is a software which is called as StatCraft P. This software is simply a menu-driven software. It is a cloud-based tool and a Make in India initiative. I've already loaded this particular data set into StatCraft P. Using this software, we will go ahead and run the Kruskal Wallis test. The first important point here is I'd like to check whether one of the important assumptions in Anova is satisfied or not. What is that assumption? The assumption that Anova makes is that there is homogeneity of variances among the groups. If the homogeneity of variance assumption is satisfied, you can proceed to use Anova itself. When the homogeneity of variance assumption fails, it's only then that we can use the Kruskal Wallis test. Let me first perform the Levin's test to check whether there is homogeneity of variances among the three groups. This is the analysis tab. Under the analysis tab, you have different options. I'll choose the third option, namely compare groups. Once I click on the drop-down menu here, you can see this is the Levin's test. We can click on the Levin's test to perform whether the variances among the three groups is same or different. Let me begin by refreshing. You can see there are three important variables in the canvas to the left-hand side. ID, I'll ignore the variable ID. Under the variable section, I'll be choosing petal length. And under the category, I'll be choosing the species of flower. This will execute the Levin's test for homogeneity of variances. I've clicked on OK. StatCraft takes a couple of seconds to run the analysis. This is the output window. In the output window, StatCraft displays the output results of Levin's test. As you can see here, this is the Levin's test for equal variances. The Python code is also displayed here. StatCraft gives you the table for Levin's test for equal variances. There are two important columns, namely the Levin statistic value, which is 19.7. StatCraft further gives you the p-value, which is 2.59 e power minus 8. Since this is e power minus 8, this p-value is very, very small. We can approximately consider this as 0.00. How do we interpret the p-value? The p-value is compared with another important statistic, namely the level of significance. We compare the p-value with level of significance. If the p-value is less than 0.05, which is the level of significance, we go ahead and reject the null hypothesis. On the other hand, if the p-value is greater than 0.05, we fail to reject the null hypothesis. In this case, you can see here the p-value is very tiny. It is less than 0.05. Since the p-value is less than 0.05, I will reject my null hypothesis and conclude that the homogeneity of variance assumption fails. So the three groups that we are talking about, Setosa flowers, versicolor, and virginica, for at least one of the groups, the variance is significantly different. So we have hit the dead end of the road. Since the Levin statistic clearly says that the homogeneity of variance assumption fails, I cannot proceed to perform the one-way analysis of variance. But we don't have to be disappointed. Statistics provides an alternative in the form of H-test. As I already mentioned, the H-test or the Kruskal Wallis test acts like a powerful alternative to the one-way Anova. Let me now go back to data. One of the important things to note here is that each of the groups should have a sample size of 5 or more. Let me quickly check whether I have got at least 5 or more samples for each of the groups. How do I do this? You can click on the analysis tab. Let me scroll up. There are different options here. The second item here is descriptives. Under the descriptive section, I can choose the second item, namely frequencies. Let's first run a frequencies to check whether we have 5 or more than 5 samples in each of the species of flowers. I'll now go ahead and click on OK. This is the output window. Let me now scroll down. You can see here, there are 3 species of flowers that is displayed along the row: Setosa, versicolor, and virginica. Please observe the frequency, it is 50. We have 50 species of Setosa, 50 for versicolor, and finally, we have 50 for virginica. So we have a healthy sample size in each of the three groups, and hence I can go ahead and proceed to perform the Kruskal Wallis H test. To perform the Kruskal Wallis H test, let me again go to the Analysis tab. Now I'll choose the option Compare Groups. The third option from the top is the non-parametric test. I'll scroll down. You can see here, this is the option for, I'll have to do this again, my apologies for this. Analysis tab, Compare Groups, Non-Parametric test, and here we have the Kruskal Wallis H test. This is the Kruskal Wallis H test. Let me click on refresh. Under the variables section, I'll be choosing petal length. And under the categories section, I'll be choosing the species of flower. So it's very simple here. You can choose any categorical variable. Typically, the categorical variable under question should have 3 or more than 3 groups, but people use the Kruskal Wallis test even when you have 2 groups. I've taken a scale variable here, but popularly people take an ordinal variable whenever they are running a Kruskal Wallis H test. Let me now go ahead and click the OK button to perform the Kruskal Wallis H test. StatCraft is running the analysis. It looks like the analysis is ready. Let me scroll down to check the output of the Kruskal Wallis test. Here we are. This is the Kruskal Wallis H test. There are 2 columns that Kruskal Wallis H test displays. The first one is the statistic value, 130.4. Look at the p-value here. It is 4.7 e power minus 29. 4.7 into 10 power minus 29, which is a very, very small number. We can approximately consider the p-value as 0.00. Now, how do we interpret this? Remember, what is the null hypothesis in the Kruskal Wallis test? The null hypothesis is that the median value of petal length for the 3 groups is the same. The alternative is that the median for at least one group is different. If the p is greater than 0.05, my apologies, if the p-value is greater than 0.05, we fail to reject the null hypothesis. In my case, what we have got is a p-value which is clearly less than 0.05. The p-value is very small. It is less than 0.05. Since the p-value is less than 0.05, we reject our null hypothesis and conclude that the median value of the petal length is significantly different for at least one group of flowers. So this is how the Kruskal Wallis H test can be used. To summarize the discussion that we've had, in this video, we've seen what are the important conditions to perform the Kruskal Wallis H test. Each group should have a sample size of at least 5 or more. Kruskal Wallis is used when you want to compare 3 or more than 3 groups. Kruskal Wallis test is a powerful non-parametric alternative to the one-factor Anova. Typically, we use the Kruskal Wallis test when the assumptions behind one-way Anova fail. So as you saw in this particular video, when the Levin statistic indicated that the homogeneity of variance assumption fails, that's when we can go ahead and use the Kruskal Wallis test instead of the one-way Anova. I thank you very much for watching this particular video. I request you to like, share, and subscribe to my videos. Thank you very much. Have a great day ahead.